In this video, I'm going to go through to show you how to find the prime factorization of a number. We're going to find all of the prime factors of a number using a factor tree. And that basically is what prime factorization is. Let's take the number 20 to find the prime factorization for it. So the first thing you do is make two branches coming from the 20. And you ask yourself, what are two factors or a pair of factors that when you multiply them together you would get 20. The key thing to remember in a factor tree is that you cannot use the number 1 in a factor tree. 1 is neither prime nor composite, so you never use the number 1 in a factor tree. So even though 1 times 20 does give you 20, we can't use this factor pair because it contains 1. So we do have a few other choices. We could start off with 2 times 10, or we could start with 4 times 5. Let's start with 2 times 10, even though it would be okay to also start with 4 times 5. So on one branch, I'm going to put one factor, which is 2. On the other branch, I'll put the other factor, which is 10. So our factor pair, 2 and 10. But it is multiplication, so we need to put the multiplication sign in between. These numbers that we are using, these are called factor strings because they are a string of factors. So our first factor string is 2 times 10. What we need to do now is look at the factor string to see if there are any composite numbers. Well, 10 is a composite number. So I need to draw 2 more branches because I can factor down 10 again. So 2 times 5 equals 10. Now the number 2 up here on the first factor string is already a prime number. However, I don't want to leave it up here all by itself. So I am just going to drop it down to the next factor string. And of course I need to put my multiplication sign. So now I have a second factor string. In my second factor string, all of the numbers are now prime. 2 times 2 times 5. So this would be considered the prime factorization for the number 20. I can also write my prime factorization using exponential notation. This would be 2 to the second power times 5. My two base numbers I used are a 2 and a 5. Of course, for the base number 2, since I used 2 of them, it would be 2 to the second power, and I only used one base number of 5, so it would be times 5. Let's look at another example. Let's take 40 and find the prime factorization for 40. Once again, remember you cannot use the number 1 in your factor tree. So as a factor pair, I could use 2 times 20 to begin with. I could also use 4 times 10. I could use 5 times 8. So any 3 of these would be fine to begin with. This time, let's use 4 times 10. So 4 times 10 is 40. In this factor string, both of my numbers are composite numbers. So that means I can continue to factor them out or have a factor pair for each of those. So for 4, 2 times 2 is 4. And on 10, 2 times 5 is 10. And I still need to bring down my multiplication sign. On my second factor string, all of my numbers are prime numbers. 2 and 5 are prime, so that is the prime factorization for 40. If I write this in exponential notation, I have the base number 2 used 3 times, so that's 2 to the third power, also pronounced 2 cubed, times 5. Now, let's use the number, let's use the number 60. The very first factor pair that I think of is 6 times 10. You could use several other factor pairs to begin with. So this time I believe I'm going to use 2 times 30. 2 times 30 does equal 60. On my first factor string, 2 is already a prime number, but 30 is a composite number. So I can put 2 branches and find a factor pair for 30. 5 times 6 is 30. Since 2 was already prime number, just bring it down along with the multiplication sign. Now in my second factor string, all of the numbers I have, 2, 5, and 6, I need to check those out to see if any of those are composite. 6 is a composite number, so it can be factored again. 6 would be 2 times 3. 5 is already a prime number, bring it down. 2 is already a prime number, bring it down, along with the multiplication signs. Now in my third factor string, 2 is a prime number, 5 is prime, we already said 2 is prime, and 3 is a prime number, so there is my final answer. So 2 times 5 times 2 times 3 is the prime factorization for 60. Or, if I want to write it in exponential notation, 2 to the second power, since there are 2 base numbers of 2, times 5, there's only one 5, times 3. Let's look at another situation that does not occur very often, but it could happen. Let's take the number 19. So if we're going to find the prime factorization of 19, we run into a little bit of a problem. 19 is already a prime number. I cannot do a factor tree that says 1 times 19, because if you recall, I said you can never use the number 1 in a factor tree. Actually, all I would need to do is circle 19 because it is already a prime number. Let's look at one final example. Let's take the number 200. Once again, we have several choices for 200. What many people would probably immediately see is 2 times 100 as a factor pair. Well, 2 is a prime number, but 100 is definitely a composite number. So I can break 100 down. 100, you could say 2 times 50. You could also say 10 times 10. So let's use 10 times 10. Since 2 is prime, we just drop it down along with the multiplication sign. Now in my second factor string, the 2 tens are composite numbers. So I will have branches coming from the 2 tens. 10 is 2 times 5. Obviously this 10 is also 2 times 5. And bring down my multiplication sign. And then I have to drop down my prime number 2. Now on my third factor string, 2's, those are prime numbers, and 5's, those are prime numbers. So this is my prime factorization. So writing the prime factorization in exponential notation would be, I have a 2 that is being used times a 5 that is being used. Those are my base numbers. But the base number 2 is used 3 times, so that's 2 to the third power, or also pronounced 2 cubed, times, and I have 2 base numbers of 5 being used, so times 5 to the second power, or 5 squared. Using a factor tree is one of the best and easiest ways to find all of the prime factors of any number.